Here we're going to be exploring f of x plus k. And what effect does k have on the function f of x plus k as compared to the function f of x is equal to x? But to make it more interesting, we're going to make it the absolute value of x. So we're going to put the absolute value bars next to the x in that question. The absolute value function f of x is equal to the absolute value of x is that f of x is negative x if x is less than 0 because the graph goes up, and it is x if x is greater than or equal to 0 because it does have a vertex at the 0, 0 point. As in the previous lesson, I'm going to use a piece of patty paper to trace the parent function. That way I can see what happens when I'm trying to look at the examples in testing for patterns. Also, just like the previous lesson, I'm on each example putting the parent function in red so that I have something to compare it to. Looking at the left example where f of x is the absolute value of the difference of x and 2, if x is 0, then 0 minus 2 is negative 2, and f of x is 0. That means my y-intercept is at 0. If x was 2, 2 minus 2 is 0, so the f of x is 2. This means that I'll be able to shift my graph 2 to the right. So I'm now going to draw that graph from its parent function 2 to the right, which is the green line that I'm now putting up onto the graph. Right now, the only relationship I'm seeing between the 2 to the right and the equation is the number 2. But my graph has a positive 2 and the equation has a negative 2. If you don't have patty paper or tracing paper, you may find it most useful to make a table of x and y values as I'm doing over here on the left. Now I'm going to do the same thing with the second example. Placing the patty paper over, I ask myself what happens if x is 0? 0 minus 1 is negative 1, and the absolute value of negative 1 is a positive 1. So I shift the vertex to the right by 1. That lets the y-intercept be a 1. At this point, I may be noticing a pattern that the 2 in the equation and the 2 on the graph seemed related, and the 1 in the equation and the 1 in the graph seemed to be related. The difference was that they are opposites of each other. So I can apply this idea by following patterns. With the third and fourth example, when I see that plus 1, I can move it in its opposite direction to the left 1 and draw the new graph. And on the fourth example, where I see a plus 2 for that absolute value, I'm going to move its parent function 2 to the left. This now brings us to a horizontal translation. That's where the graph moves left or right by the opposite value of k. Those horizontal translations moving in the opposite direction, that's completely counterintuitive from what we've seen in the last lesson. So this is a good keynote for us to keep track of. And remember, math gets lonely, so spend some time and play with it.